The full narrative of the engagement that occurred on February 27, 1943, north of Kasserine Pass in Tunisia, could never fully capture the sights witnessed by German tank commanders that morning. American Sherman tanks performed maneuvers that defied all established Wehrmacht doctrine regarding what was feasible without visual signaling. Through the obscuring dust and smoke of the North African battlefield, 5 Sherman tanks, separated by fractured terrain and lacking a direct line of sight between them, converged upon German positions with seemingly preternatural timing. There were no signal flags, no flares, and no dispatch riders speeding between the vehicles. Nonetheless, they functioned as a cohesive unit, with each tank covering the blind spots that others could not see. Each crew knew the precise location of their comrades. Meanwhile, German Panzer IVs, equipped with FUG-5 radios, had commanders struggling to discern their own company leaders through static that overwhelmed their amplitude modulation, AM systems. The 10-watt German transmitters, which had been state-of-the-art by 1930s standards, could not penetrate beyond a few hundred meters when the tanks were in motion. Furthermore, most German tanks only carried receivers, leaving them unable to report observations or call for assistance. The Americans were utilizing a technology entirely unknown to the Germans. This technology involved frequency modulation, FM radios installed in every single tank, featuring crystal-controlled precision, 25 watts of transmission power, and a clarity that sliced through engine noise and the surrounding chaos of the battlefield effortlessly. 8,000 miles from Detroit's production lines, the most significant technological edge of World War II was being unveiled. This advantage resided not in the thickness of the armor or the caliber of the gun, but in the unseen electromagnetic waves that linked every American tank crew in ways the Wehrmacht had never conceived possible. The shift commenced on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR 508, SCR 528, and SCR 538 for use across all medium tanks. As German forces pressed deeper into the Soviet Union, using tactics reliant on radio communication solely between command vehicles, American engineers at the Galvin Manufacturing Company, later renamed Motorola, were perfecting the FM technology that would render German systems obsolete. The engineering team included Daniel E. Noble, who first envisioned applying FM technology in military vehicles, and Henryk Magnowski, the primary RF engineer who overcame the technical difficulties of installing complex electronics within the rugged environment of a tank. Their resulting creation weighed 181 pounds and transformed every Sherman tank into a node within the world's inaugural battlefield network. The BC-604 transmitter generated 25 watts of power, which was 2.5 times the output of the German FUG-5. Operating in the 20.0 to 27.9 MHz frequency range, it offered 10 preset channels with crystal-controlled stability. The dual BC-603 receivers in the SCR 508 allowed commanders to simultaneously monitor multiple frequencies, a capability that would prove decisive in combat. The true innovation, however, lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed for military use, effectively eliminated the static and interference that perpetually hindered AM systems. Whereas German tank radios registered every electrical discharge as noise, American FM radios maintained clear voice communication even during artillery bombardments. On November 8, 1942, Operation Torch brought American armor to North Africa. The tanks of the 2nd Armored Division landed near Safi and Fadala, equipped with SCR 508 radios that would soon demonstrate their superiority over German communications. The Africa Corps, despite being the Wehrmacht's most seasoned armored force, operated under severe communication constraints. A typical German tank platoon of 5 vehicles included only 1 or 2 equipped with the full FUG-5 transceivers, capable of both transmission and reception. The remaining tanks were outfitted solely with FUG-2 receivers. They could receive orders but were unable to reply or report enemy positions. German tank platoons operated under a rigid hierarchy. The platoon leader transmitted orders, and subordinate tanks acknowledged them through actions, not words. When command tanks were eliminated, easily identifiable by their multiple antennae, the entire platoon's coordination was lost. This vulnerability proved devastating against American forces, where every tank was capable of assuming command functions. The Battle of Kasserine Pass, which took place from February 14th to the 24th, 1943, served as the first major demonstration of American radio superiority. Although it was a tactical German victory, the battle revealed capabilities that astonished Wehrmacht observers. During the chaotic fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of the battlefield. Tank crews who had never met coordinated attacks issued warnings about threats and requested artillery support using crystal-clear FM communications. German signals intelligence units intercepted the American transmissions and noted their exceptional clarity and coordination. The intelligence section of the 10th Panzer Division reported that American units sustained communication at ranges where German radios produced nothing but static. More alarming was the discovery that every American tank appeared capable of full transmission, not just the designated command vehicles. The German FUG-5 radios, which operated on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental limitations. Their 10-watt transmitter struggled to reach 2 to 3 kilometers under ideal conditions, diminishing to mere hundreds of meters when the vehicles were moving. Every firing spark plug, every electric motor, and every track movement generated interference that AM systems were unable to filter out. September 1943 brought American armor into Italy, where the mountainous terrain should theoretically have nullified any radio advantage. Instead, FM technology proved even more valuable in conditions that rendered German AM radios completely useless. The SCR-508's frequency modulation managed the multipath interference prevalent in mountain valleys far more effectively than amplitude modulation. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed entirely during the advance towards Cassino. American armored units exhibited capabilities that defied German comprehension. Tank platoons, separated by ridgelines, coordinated attacks with a precision that German doctrine deemed impossible without visual contact. After-action reports from the 1st Armored Division routinely described coordination at distances where German radios were only producing static. On June 6, 1944, as Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with naval fire support, a coordination task that was impossible with German technology. However, the hedgerow fighting quickly exposed a critical gap. Tank radios could not communicate with infantry radios, which operated on entirely different frequencies. The infantry's SCR-300 operated on 40.0 to 48.0 MHz, incompatible with the tank's 20.0 to 27.9 MHz range. This communication lapse proved lethal in the bocage, where German infantry armed with Panzerfausts could approach American tanks while nearby American infantry had no means to issue a warning. American innovation resolved the issue within weeks. Tank crews mounted EE-8 field telephones in ammunition boxes, which were then welded to the tank exteriors and wired directly to the internal communication system. By Operation Cobra in late July, this straightforward modification had revolutionized tank infantry cooperation. From July 25th to the 30th, 1944, Operation Cobra demonstrated the full extent of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that allowed for unprecedented control over the battlefield. German defenders from the Panzer Lehr Division found themselves facing an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away. Artillery strikes, coordinated via tank radios, arrived within minutes of target identification. The difference with German capabilities was profound. Panzer Lehr, once Germany's elite armored division, had been reduced to communication poverty. Most of their tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios they did possess suffered from interference and limited range, preventing effective coordination. The irony was significant. Germany had pioneered the use of radio in armored warfare. Heinz Guderian, the creator of Blitzkrieg, had been an advocate for equipping tanks with radio sets since the 1920s. His book, Achtung, Panzer, published in 1937, stressed communication as an essential element of armored operations. Guderian had developed radio communication systems that allowed tank officers to coordinate attacks. He understood that rapid armored advances required dependable communication. Yet, by 1943, German tank production was unable to supply the very radios that Guderian's own doctrine demanded. German production figures revealed the severity of the crisis. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Many of these radios were allocated to command vehicles and assault guns, leaving regular tank units desperately lacking communication equipment. Soviet tank forces experienced even greater communication deficiencies. The T-34, despite being the most produced Allied tank, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning, which resulted in catastrophic losses against German forces in 1941. By 1943, the Lend-Lease program offered some assistance. American radios, including SCR-508 sets, were used to equip Soviet command tanks, but even by the war's conclusion, only about 25% of Soviet tanks carried radios. The comparison highlighted the American accomplishment. While the Soviet Union struggled to equip 1/4 of its tanks with any radios, America achieved 100% deployment of advanced FM systems. Motorola's Chicago facility exemplified American industrial mobilization at its peak. Before the war, the company produced car radios. Converting to military production necessitated a complete retooling and the resolution of unprecedented technical challenges. Each SCR-508 required 2,748 individual components manufactured to rigorous standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite extreme temperatures and combat vibrations. Production statistics illustrate the force of American industrial capability. 3,800 SCR-508 family radios in 1942, 11,400 units in 1943, and 24,000 units in 1944. Total wartime production exceeded 50,000 tank radio sets. This production feat guaranteed that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement unmatched by any other nation. The advantages of the SCR-508 went beyond simple frequency modulation. Crystal-controlled frequency stability meant that tanks could preset channels before a battle and maintain alignment despite combat conditions. German FUG-5 radios, which used variable capacitor tuning, constantly drifted off frequency. The dual receiver setup permitted commanders to monitor their platoon net and the company command net simultaneously. Orders flowed instantly down the chain of command, while commanders retained an awareness of the subordinate unit's situations. The BC-606 intercom system integrated seamlessly with the radio, enabling all crew members to alert the commander to threats. Throat microphones and noise-canceling headphones ensured clear communication during combat. Many German tanks completely lacked intercoms, forcing crews to communicate by shouting or touch. Power management presented another American advantage. The SCR-508 could operate on either 12 or 24 volts, adjusting automatically to the available power. The dynamotor power supply delivered stable, filtered power that eliminated electrical interference. German radios, powered directly from the vehicle's electrical system, picked up every spark as static. The tactical benefits of deploying radios universally transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, was entirely reliant on trustworthy communications. American commanders could create ad hoc battle groups from different units, confident that coordination would be maintained through compatible radios. This flexibility perplexed German commanders who were accustomed to rigid organizational structures necessitated by limited communications. During the Battle of Aricourt in September 1944, the 4th Armored Division encountered multiple German Panzer brigades equipped with superior Panther tanks. The Germans held every advantage in armor and firepower, but American radio coordination proved decisive. Every Sherman tank could instantly report enemy positions. Tank destroyers received targeting information from tanks they could not see. Artillery observers in Sherman command tanks called in devastating barrages within minutes. Over 3 weeks, the 4th Armored Division destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that defied technical specifications. Throughout the war, German intelligence failed to grasp the importance of American communication superiority. Combat reports mentioned the American coordination, but attributed it to training rather than technology. A captured intelligence assessment from September 1944 stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely overlooked the technological advantage. German tactics never adapted to the American capabilities. They persisted in targeting supposed command tanks based on antenna configurations, failing to realize that every Sherman could coordinate battlefield responses. They planned ambushes, assuming American tanks would lose coordination when separated, not understanding that radio contact maintained unit cohesion regardless of visual contact. By March 1945, as American forces neared the Rhine, their communication superiority reached its peak. The capture of the Remagen Bridge demonstrated the speed of American command and control. When the 9th Armored Division discovered the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to capitalize on the opportunity. German forces, relying on telephone lines that American aircraft systematically destroyed, could not respond with comparable speed. American radio coordination established an impenetrable defense of the bridgehead. Tank platoons from various battalions integrated flawlessly, coordinating their fire through radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. April 1945 saw the encirclement of the Ruhr Pocket, which represented the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had completely broken down. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with both higher headquarters and each other. Field Marshal Walter Model's final messages before communication failure revealed the German predicament. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority deeply impacted the psychological experience of tank warfare. American crews fought with the assurance that they were never truly alone. Even when physically isolated, they remained connected by radio waves. German tank crews experienced the opposite, profound isolation. Unable to communicate, they fought individual battles within larger engagements. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir, Tigers in the Mud, about the difficulties of limited communications, though he focused more on tactical aspects than the communication gap itself. The strategic implications extended beyond individual battles. American advances in 1944 to 1945 maintained their momentum partly through radio coordination that German forces could not match. The Third Army's rapid sweep across France relied on radio networks that maintained control across hundreds of miles. German commanders consistently underestimated American capabilities because they could not conceive of the communication superiority the Americans possessed. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but was unable to resolve it. In a December 1944 memorandum, he conceded that American coordination negated German advantages in tank quality. After Germany's surrender, American technical intelligence teams evaluated German equipment. Their findings validated what combat experience had indicated. German tanks often boasted superior armor and armament, but suffered from catastrophically inferior communications. U.S. Army Technical Intelligence Report No. 176 concluded that German tank communications equipment was approximately 5 years behind American systems. The lack of frequency modulation, restricted radio distribution, and inadequate electrical suppression created critical vulnerabilities. Soviet evaluators reached similar conclusions. The Red Army, having access to captured German equipment, opted to copy American radio designs rather than German systems for post-war development. Production and deployment statistics reveal the scale of the American achievement. America produced over 50,000 SCR 508, 528, and 538 radios, corresponding to the 49,324 Sherman tanks produced. This resulted in a radio deployment rate of 100%. American transmission power was 25 watts, with crystal-controlled frequency stability of plus or minus 0.01%. The range while moving was 7 miles and 10 to 15 miles when stationary. In contrast, Germany produced approximately 6,000 FUG-5 transceivers for 12,000 medium and heavy tanks. This meant a full transceiver deployment rate of only about 20%. German transmission power was 10 watts, and frequency stability was a variable plus or minus 1%. The moving range was only 0.5 to 1 mile, dropping to 2 to 3 miles when stationary. In terms of communication effectiveness, the average time for an American fire mission was 3 to 5 minutes, compared to 15 to 30 minutes for a German fire mission. 100% of American tanks achieved coordination versus only 20% of German tanks with full communication. The radio superiority of Sherman tanks established principles that continue to govern armored warfare today. Modern main battle tanks carry communication suites that directly trace their lineage to the SCR 508, relying on digital rather than analog technology, but fundamentally based on universal deployment and reliable coordination. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based on the lessons of World War II. Every Leopard tank ever manufactured has carried comprehensive radio systems. A Bundeswehr training manual explicitly notes the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts affirm this lesson. In the 1991 Gulf War, coalition forces with superior communications overwhelmed Iraqi forces equipped with individually superior Soviet-designed tanks but inferior radios. In 2003, American forces once again demonstrated that network-centric warfare defeats platform-centric warfare. The narrative of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. German tank crews fought their war partly oblivious to this revolution. They discovered too late that every Sherman tank was not merely a fighting vehicle, but a node in history's first battlefield network. The SCR 508 radio transformed the M4 Sherman from an adequate medium tank into a component of a weapon system that included every other American tank on the battlefield. This transformation was more consequential than any improvement in armor or firepower could have possibly achieved. Every Sherman tank carried the tools of victory, not solely in its 75mm gun or sloped armor, but within the 181 pounds of radio equipment that connected its crew to every other American tank crew. This interconnection created a collective intelligence that no single German tank, regardless of its superiority in armor or firepower, could match. German forces came to this realization through difficult experience. At Kasserine Pass in the mountains of Italy, across the hedgerows of France, and in Germany's final battles, American tanks demonstrated a level of coordination that German doctrine claimed was impossible without visual contact. The Wehrmacht never developed an effective countermeasure, because they never fully grasped the technological disparity. Field Marshal Wilhelm Keitel's purported comment at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," captured a fundamental truth, whether accurately quoted or not. America had constructed not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs, which historians identify with modern network-centric warfare, actually began in 1942 when the first Sherman tank equipped with an SCR-508 radio entered combat. From that point forward, warfare was irrevocably altered. The side with superior communications would defeat the side with superior weapons. The network would overcome the platform, and the connected would triumph over the isolated. This fundamental shift occurred largely undetected by German forces. They observed American tactical superiority, but failed to recognize its technological underpinning until far too late. By the time German commanders understood that every Sherman tank possessed communication capabilities that most German tanks lacked, the war was effectively decided. The German military's failure to acknowledge and adapt to American communication superiority is one of World War II's greatest intelligence failures. Despite countless engagements demonstrating the American coordination advantage, the German leadership never prioritized solving their critical communication weakness. They continued building superior tanks that fought as isolated individuals, while American forces built adequate tanks that fought as coordinated teams. Ultimately, the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns. The capacity to coordinate, to instantaneously share information, and to fight as a unified force rather than as individual vehicles. This invisible advantage determined victory more certainly than any visible superiority in armor or armament. The radio superiority of the Sherman tank changed warfare forever, establishing the principle that in modern combat, connection equates to survival and isolation equates to defeat. German troops discovered this reality on battlefields across 3 continents, learning too late that the Americans possessed not only numerical superiority, but technological superiority in the dimension that mattered most, the ability to fight as a unified entity.